Hello. In this video, we're going to look at a table of a quadratic function to answer the questions that follow. Okay, so here we are told that we have the table of a quadratic function, and here it is, but we do not have a image. So we're asked to answer all of these questions, but we kind of just have to get a visual for what the function looks like. So when I'm asked these questions, I always try to, let's pick a nice color. I always look for like the vertex first, because when we think about a quadratic function, it's either going to be a smiling or a frowning concave up or concave down parabola, and I want to know what I'm dealing with. So the turning point is really important. So let's see if I can find it. I'm looking for symmetry. Oh, I see repeated 12s. I see repeated 9s. See this? Repeated 9s, repeated 12s, which means my axis of symmetry or my vertex needs to be right in between. We're always looking for our vertex first, okay? So I found my vertex. Okay, nice. Now I have to decide, is it a concave up or a concave down parabola? So let me look at my y values. I've got 13. Then I've got lower at 12 and 12. I've got lower at 9 and 9, meaning this is a maximum. It's the highest value. So when I look at these two quadratics, which one has a maximum? It would be this guy here. So my vertex is at 12, 13, and this is the picture I'm dealing with. So when you're working with tables, guys, I would always suggest to make a sketch before you answer any questions. Sketch first. Okay, so here's my little sketch. All right, so what are the coordinates of the turning point? So easy. The turning point is the same as the vertex, so 2, 13. No way are they asking me if it's a maximum or minimum. Well, because I have this sketch, it's easy to say, oh yeah, it's a maximum um, because it's the highest point. Nice. All right. So now they're talking about range, and I really want you to get in the habit of when you see the word range, you're going to write y values. Okay. So I'm looking at my y's. Now that I have this sketch, I can kind of decide my lowest low and my highest high. I know I'm going to have y on one side, and I know I got to have 13. Now I need to decide on my inequality. Okay. Am I looking at values below 13 or above? Well, since my arrows are coming from below, I'm going all the way up to 13. So y has to be less than, left hand less than, or equal to, because I can equal 13. Done. Axis of symmetry. Always make that big X, because that's a signal to you that you know it has to be X equals. The axis of symmetry is just what cuts my parabola perfectly in half. Writing that X equals signals to me, oh yeah, I got to look at the X. I have to look at the X coordinate. So it's going to be X equals 2, the X coordinate of my vertex. These ones are my favorite. What is f of 4? Okay, so usually my function is named f of x, right? So what we've done is we've replaced 4 with x. Other way around, x with 4. So it wants me to go to where x is 4. And what is it equal to? Oh, 9. So my answer here is 9. This is going the exact opposite way. So in this case now, they're saying, hey, you, f of x is equal to 4. All right, well, look, f of x, I'm in the f of x column, and that's equal to 4. What is the value of x? Oh, 5. So these questions are cool because they're like little puzzles. You just have to kind of, understand what they're talking about here. So that is our first dealing with tables. Sometimes you see tables going vertically, and sometimes they just really get crazy trained and they show you horizontal tables. I'm going to tell you again that this is a quadratic function. So as with any quadratic, you're always going to see if you can find the vertex, and we're always going to look for symmetry in your y's. So I see a 0. Do I see a 0 anywhere else? Oh, right there. So let's see. Now I'm going to start going up. -3, -3, which means I have found my vertex. Once you find your vertex, always label it. So this is my vertex. Now I need to decide, is my vertex a maximum or a minimum? Is my parabola concave up or is it concave down? So let's see. You're looking at your y's. -4. Then I've got -3 and 0. It looks like they're going up, which means my parabola is looking like this. Okay, so that might be useful for us. We'll see in the questions. All right, what are the x-intercepts? So if I think of x-intercepts, that's where my y is equal to 0, and we've talked about this before. Y equal to 0. So in this case, my y is represented by g of x. Oh, I see them. X-intercepts are happening here at -9, and where else? Oh, at -5. So you can either write them as a point, -9, 0, and -5, 0, or you can write them as x equals. Either's fine with me. Range. Do you see why having this picture is helpful? Range is lowest low to highest high, and range I'm always going to write y. So I know y, and I know the other y that I'm interested in is -4. Now I need to decide, am I going above -4 or below? And when I look at this picture, I know I have to go above, so it's greater than or equal to. Last but not least, hey, identify the vertex. I already did that, -7, -4. And is it a maximum or minimum? Well, hey, since I drew the picture, I know that the vertex is a minimum. All right, so I hope this was helpful with you to help you look at tables and analyze quadratics. It's been real.